Hi, my name is Gutierrez and I'm a senior here at UNC. So the reason that I want to be a mentor is because I know how exciting it is to achieve that aha moment when you finally understand something. And for me, with all the chemistry courses that I've taken here at UNC, I've had many of those aha moments, but it's always been facilitated by a chemistry mentor. And I would just love to be a part of that process, to be able to give someone that aha moment, and that would just really make me happy if I could do that. So today we're going to work through a synthesis problem. And typically I like to just look at the product and see what I have in order to figure out what I can get, sort of kind of like working backwards. So here we have our two alkyl groups. We're going to focus on these first. I'm going to focus on this isopropyl group here first. So in order to achieve alkyl groups onto our benzene ring, we typically use Friedel-Crafts alkylation. So with Friedel-Crafts alkylation, so we're going to use our propyl chloride, and we're going to use aluminum tetrachloride. And with Friedel-Crafts alkylation, you typically will receive the rearranged product. So instead of what you would think you would get, which is this, it will be rearranged to be the more stable one, which is this isopropyl group. Okay, so now we have our isopropyl group, and now we're going to focus on our next alkyl group here. So as you can tell, it's unrearranged. So that's kind of giving us a hint that we're going to not be using Friedel-Crafts alkylation, but we're going to be using Friedel-Crafts acylation. So acylation will typically give you the unrearranged product. So with acylation, we're going to use a butyl chloride and aluminum tetrachloride. So then this group, the position where I'll end up, will be dependent upon this group. So because this group is activating, well, weakly activating, it will be the director. So we'll direct it to be either ortho or para, but it will be para because of steric hindrance. So it will end up over here. So you'll end up with something like this. So, because we have a carbonyl group here, we will look at this towards the end to get rid of it, but we're going to do a reduction. Right now, we're not going to do it just because we want to get our chlorine here to be para here, and we want this to be our director. So, this isopropyl group will be the director. So now we're going to do chlorination. And to do chlorination, we do dichlorine, and we do iron tetrachloride. So then we add this, and this is the most electron donating, so it's most activating, so we'll direct it to be ortho because that is what we have here. And then we're going to add H2 and palladium in order to reduce this and get rid of the carbonyl group, and that is how we end up with our final product here.